So I've already made a start on this question. I saw there was a linear factor here, so I know that's just a constant over that linear factor. And I saw I had a quadratic factor here that doesn't factor, so we're going to write that as something x plus a constant term over that factor. So in other words, something that's linear. I then did the cross multiplying here, so I got ax squared plus 1 plus bx plus c times x plus 2. I know both of these are divided by this, so I've just not written the common denominators here, but we can just go ahead and try and solve here. So first one, look for nice values. I see negative 2 as a nice value here, so if I plug negative 2 into here, this would be 12. Minus 2 times negative 2 would be 4, minus 1, equals, negative 2 squared is 4, plus 1 is 5, so 5 times a. This becomes 0, that's why I did it. And notice this side is 15, so if 15 equals 5a, what we can say then is a equals 3, and in a second we'll work out b and c. Now there's no more special values that we can choose to make one of these sets of parentheses equal to 0, so we'll have to try our other tricks. So let's compare coefficients of x squared. On the left hand side we've got 3, this side we've got a, and here we have b. As we already know that a is 3, that should tell us that b equals 0. Once again, perfectly okay to have b as 0. To find the other value, we're going to do the same trick we did before. We're going to look at the constant term. So on the left-hand side, we got negative 1. A times 1 would give us a constant, so that will be 1a. And on the right-hand side here, c times 2 is 2c. As we know that a is 3, we can substitute that in. If we subtract 3 from both sides, and therefore we can say that c equals negative 2, and we can go and substitute those values up into our question. So this would be 3, there was no x, it was just a constant term this time, it was negative 2, so we can go ahead and write subtract 2. Now the question asks us to differentiate this. So first of all, I've gone and rewritten these with negative exponents. And if we want to differentiate this, we can use the chain rule to do this. So this is what y equals. So dy by dx would equal, bring the power down to the front and multiply, decrease the power by 1, and then times by the derivative of what's inside the parentheses, which for this case is 1, so we don't need to do anything else. For our second one, bring the power to the front and multiply, decrease the power by 1. This time the derivative of what's inside the parentheses is 2x, so we can do a little bit more this time. And if we go ahead and tidy this up now, the negative exponent we can bring to the bottom. 2 times 2x is 4x. And the negative exponent, once again, we can bring to the bottom. So what would have been a very difficult question before, by using partial fractions, suddenly becomes something that's much easier to work with.